Hi everyone, today we are going to talk about triangles and quadrilaterals. They are specific shapes. So we're moving on from angles to talk about shapes now, two-dimensional shapes. And we're first going to start off by talking about triangles and the different types of triangles. So normally when you see different designs, you will actually see that there are triangles inside of those designs. So these three are examples of where you can see triangles in the designs. So there are many different types of triangles. As you see, these different triangles they just look different. They're not exactly the same, right? So we have specific names for them based on their sides and angles. So first off, when we look at the number of equal sides in the triangle, there are different types. So a scaling triangle is when there are no equal sides. All three of the sides are unique. They're not the same. Isosceles triangle is where you have two equal sides. So this is an example right there. And normally you will see in textbooks or in drawings, diagrams, that if there are two equal sides, just like for two equally measured angles, you'll see the same number of ticky marks there. Same with, like we talked before, with parallel lines, you'll see the same markings. It just shows that they are equal in measurement. So with the equilateral triangle, all three sides are equal, and you'll see that all three of the sides show the same marking to show that they are the same measurement. Okay, so scaling is when there are no equal sides. Isosceles, only two sides are equal. Equilateral, all three are equal sides. And interestingly enough, the equilateral triangle, since all three sides are equal, that means that all three angles are equal. It forces those angles to be the same. And with the isosceles triangle, the opposite angles to the equal sides are also equal. So the sides and the angles actually are working together in each shape. That's just like an extra piece of information. All right, the other way we can categorize triangles is by looking at their angles and the types of angles they have. An acute angled triangle, that's a mouthful, is when you have all angles that are acute. All three angles are acute. You can call it an acute angled triangle. Okay, and then a right angle triangle is when one of the angles is a right angle. Notice how it says one of the angles is a right angle, because that's the only possibility. If you have one angle that's a right angle and another one that's a right angle, well, it can't close up to create a triangle, right? So one is the max. That's the only possibility there. An obtuse angle triangle is when one of the angles is an obtuse angle. And that also is the only possibility, because if you had another, remember obtuse means that it's larger than the 90-degree angle, right? It opens up wider than the 90-degree angle. If I had another one, well, then that again can't close up. It would need a fourth side, right, to even close up, and then that wouldn't even be a triangle anymore. So very important that once you have one angle that's 90 degrees or greater, like that's it, that's the cap, because you still need another side for your triangle, and it's kind of forced to then become a smaller angle. The larger these angles are, the large angles are, the smaller the other angles have to be to kind of compensate for it, to close it up, because now the angle is so wide that it has to close up a little closer. With the acute angled triangle, all three can be acute to close up, okay? all three of them. I'm going to draw different markings to show that they are different angles. All right. And next up, we're going to talk about the triangle inequality theorem. It kind of goes back to what we were talking before about how your triangle has to be able to close up. So with the triangle inequality theorem, it basically says that the sum means that when you add it up, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, so the two smaller sides have to, when they add up, they have to be greater than the length of the third side. So we're going to look at some 3 different examples. Okay, so in this first triangle, this is where the sum of the two sides, 4 and 5, are not greater than the length of the third side. Okay, 5 plus 4 is less than 10 because 9 is less than 10, right? Now, if I were to try and close this up, I wouldn't be able to, because if I were to swing this 4 side down, it would be right here. And if I were to swing this 5 side down, like swing it down, it would be down here, and then there would be a gap in between. So I literally cannot close this triangle to make it an enclosed shape. It doesn't have enough of that fencing up on the top to make it a pointy end and make it into a triangle. Okay, it's like missing some space there. It just needs a little bit more. Okay, in this example right here, I'm going to use a different color. I have one leg as 1, and then I have another, well, not a leg, but a side as 2. Okay, 1 plus 2 is equal to 3. So meaning if I were to swing these two sides down, it would lay right here 1 and right here 2. And it also wouldn't be able to close up and create a pointy end that makes it a triangle, because it would just lay down and just be right on top of that 3 and become a line. So it wouldn't be able to work. Doesn't work. Okay. So if it's smaller, if their sum is smaller or less than 10, this third side, it doesn't work because it doesn't have enough. It needs just a little bit more to close up. And then if it's exactly, the sum is exactly equal to that side, it just becomes a straight line. And it doesn't close up as well to make a triangle. Okay, so it's very specific. Now here, this 7, 8, and 10 triangle, it does work because it follows this theorem. 10 is that third side. 8 and 7, if we add them up, it is going to be greater than 10 because 8 plus 7 is 15. 15 is greater than 10. So it does make a triangle. It has that that extra length to get pointy and away from that 10 and create a triangle. So this is the only one that creates a triangle. Because when you add up both the two sides, they are greater than that third side, 10. Same if you were to add 8 and 10. 8 plus 10 is greater than 7. 7 plus 10 is greater than 8. Any of those two sides added up has to be greater than that third side. Okay, so it's not like it has to be a certain side that we're talking about. Okay, so if it's less than, then it doesn't close up. If it is equal to, then it just drops down, becomes a line. So it's got to be a sum that's greater than the third side. So it has enough to make a triangle. That's your triangle inequality theorem. Okay, and now let's move on to talk about quadrilaterals. Quadrilaterals are just like your triangle, it has to be a closed plane figure. It has to close up, right? Just like before, if our triangle doesn't have enough to close up, it's not a triangle. It just looks like, I don't know, a weird drawing, right? But it's not a triangle. So with your quadrilateral, it also has to close up. Okay, it can't have any spaces in between. Now, quadrilateral also has to have 4 straight sides joined by 4 vertices. So make sure that that goes into your notebook. Now, the pictures above right here show quadrilaterals that we find in our daily life. We see quadrilaterals when we see square tiles. We see quadrilaterals in a picture frame, which is a rectangle, and we see quadrilaterals in a ladder as well. This diagram right here, which is quadrilateral A, B, C, D, has the sides AB, has side BC, CD, and DA. Okay, those are the 4 sides, and then they close up. So that means that satisfies that qualification. They're 4 straight lines, and they're joined by 4 vertices. A, B, C, and D are the vertices. A vertex is the singular, so you can have one vertex, and you have 2 vertices. That's just the plural form of vertex. So a vertex is basically like the pointy end where the 2 lines meet. Just like how in an angle, like this is angle CAB, this is the vertex, the pointy end. Okay, so vertices is just the plural form of it. Okay, so they are 4 straight sides joined by 4 vertices. Okay, and then a quadrilateral is just named by saying the order in either clockwise, the direction that a clock is going in, or counterclockwise, the opposite direction. You just can't name it like D, B, C, A. It's gotta be in order of how you draw it, essentially. Okay. And then other vocabulary word is that the line segments in this quadrilateral, AC, which is joining the opposite vertices, AC, and also BD, those are called the diagonals. And it makes sense, right? Because they're diagonal to each other. There's no other diagonals I can draw, right? Because there are only 4 vertices. If I connect the pairs of diagonals, that's 2 diagonals. So each quadrilateral has to have 2 diagonals. That's all it can have because it's limited by the vertices. Okay, so that's quadrilaterals. Now here are some special quadrilaterals. These are all considered quadrilaterals. A parallelogram is just a special type of quadrilateral, kind of like how a poodle is a special type of dog. A rectangle is a special type of quadrilateral. So quadrilateral is basically the general name. And I like using dogs as an example. Okay, because dog is the general name. But then you can have different types of dogs, right? Like a poodle, a bulldog, a chihuahua, I don't know, golden retriever, right? So people often forget that these are all just types of quadrilaterals. They're special. Parallelogram, rectangle, rhombus, square, and trapezoid. Those all are closed, 4-sided. They all have 4 straight sides with 4 vertices, right? Because a quadrilateral's definition is very vague, right? As long as you have 4 sides, 4 vertices, and then the last requirement is that you have two pairs of diagonals, right? So that's all of these figures. But of course, they look also very different from each other, right? So a parallelogram has to have two pairs of opposite sides that are parallel to each other. So the top and the bottom are parallel to each other, and the left and the right are parallel to each other. The rectangle and the square both are composed of all right angles. A four-sided figure can have all right angles, not a triangle though. A square has all equal sides, so I'm going to draw the same symbol there, while the rectangle has opposites that are equal to each other, right? That's why a rectangle can have that longer length, right? So actually, fun fact, a square is a type of rectangle because a square has opposite, sides that are equal to each other. It just has all of the sides that are equal to each other. Okay, so a square is actually underneath the umbrella of rectangle. And then the rhombus and trapezoid. So a trapezoid and a rhombus, you probably recognize these shapes, right? Usually we call rhombi, kind of like diamonds, right? That's not the mathematical term, but I like to think that they look like diamonds. And we have seen trapezoids before. So a trapezoid is kind of like the parallelogram, except you know how on the parallelogram the opposite sides have to be parallel to each other? Well, for a trapezoid, only one pair of opposite sides has to be parallel to each other. So the other opposite sides doesn't matter. So that's why it kind of has like a lampshade shape to it, because it has the least amount of restrictions. And then a rhombus is kind of like a parallelogram where the opposite sides are parallel. And then it's also kind of like a square. It's like a parallelogram square in my mind. So it has the same requirements like a parallelogram, and it's slanty, kind of not like a square, because not only does it need equal lengths, but it doesn't have that 90-degree angle requirement. So that's why it looks more like a diamond for the rhombus. Okay, that wasn't very mathy of me. So I'm going to actually show you two diagrams next that'll help you kind of understand it more. Okay, so in this diagram, you'll see that, like we said, quadrilateral is the general term for just any closed-sided, four-sided figure that has, the four vertices and all that. Okay, and then you can break it down into either, do you need two pairs of opposite sides that are parallel to each other, or one pair? Okay, if it's two pairs, then it's a parallelogram. If it's just one pair of opposite sides that are parallel to each other, that's your trapezoid. Okay, and trapezoids come in many sizes and shapes and angles and all that. So it could look like this or it can look like that. Isosceles, as you remember, means that there are two sides that are the same length, right? So for your isosceles trapezoid, it would just satisfy all the requirements for a trapezoid, but then these two opposite sides are exactly the same length. Now underneath parallelogram, you either have a rhombus or a rectangle. Remember that a rectangle just needs to have all four angles are right angles, the 90 degrees. Doesn't say anything about the sides being equal. If they are equal, then it's a square, right? Now a rhombus is that diamond shape because it doesn't need the 90-degree angles, right? This rhombus can have obtuse opposite each other, and then acute opposite each other. That's why it ends up looking like a diamond. And then it kind of is leading to the square as well, because it kind of is like a square because it does have the equal sides and it has the 90-degree. So that's why the square actually is the most particular of all of these quadrilaterals. And then if you wanted a breakdown of all the, characteristics, here's a checklist of all of that. You can look more deeply at their characteristics. The orange characteristics are for, or checklist items are for the sides. The kind of light green is for the angles, and then the purple is for the diagonals. Okay? So like it says, for the note, a rectangle with equal adjacent sides is just a square. So that's why a square is a special rectangle. A rhombus with 4 equal angles is a square. So a square is a special type of rhombus. So that's why in this diagram here you have the square kind of shooting off from both the rhombus and the rectangle.